So students, today we will go for particle nature of light. In the last class, we observed that the wave nature of light cannot explain the laws of photoelectric effect. Now we will go for the particle nature of light, or that is called Planck's quantum theory of light. So according to Planck's quantum theory, light consists of small particles or energy packets. So these energy packets or particles of light are called quanta or photon. Now, if frequency of light is f and wavelength is lambda, then energy of each photon E equal to hf. We can write it also hc by lambda. So, if the frequency of light is f and wavelength of light is lambda, then energy of each photon will be hf. It is equal to hc by lambda. So, if there are n photons, then total energy of light will be nhf. So, the total energy of light is quantized. That's why this theory is called quantum theory of light. Next, we will go for Einstein's theory of photoelectric effect. Now, Einstein used Planck's quantum theory to explain photoelectric effect. Now, according to Einstein, photoelectric emission is one photon, one electron phenomena. So, one photon interacts only with one electron. That means only the total energy of a photon can absorb only by one electron. Now, consider a metal surface. Now, light of frequency f is falling on it. Now, consider an electron which absorbs a photon of the light. So, the total energy absorbed is hf. Now, this energy is utilized in two ways. A part of energy is used to emit the electron just from the metal surface. This amount of energy is called work function. The rest amount of energy is utilized as the kinetic energy of the photoelectron. Now, when the electron is emitted from the metal surface, during its emission, it collides with other electrons and as well as the ions of the metal. That's why different electrons have different amount of kinetic energy. But if an electron doesn't have any collision, its kinetic energy will be maximum. Now, the total energy absorbed by the electron is hf. That is the energy of the photon. Now, the energy consumed to emit the electron from the metal surface is W0. The remaining amount of energy is its maximum kinetic energy. So, from law of conservation of energy, we can write K max equal to hf minus W0. This is our equation 1. Now, if F0 is the threshold frequency, the minimum energy of the photon required for photoelectric emission is hf0. If F naught is the threshold frequency, then the minimum energy of the photon to emit the electron is hf naught. But this is equal to work function. So we can substitute W naught equal to hf naught. That implies K max equal to hf minus hf naught. We can write it as h common f minus f naught. Now f equal to c by lambda, f naught equal to c by lambda naught. So K max becomes hc common 1 by lambda minus 1 by lambda naught. This is equation 2, this is equation 3. Now the equation 1, 2 and 3 are the Einstein's photoelectric equations. So if V naught is the stopping potential, then EV naught equal to K max. It is equal to half m V max square. From Einstein's photoelectric equation, it is hf minus w naught equal to h into f minus f naught equal to hc into 1 by lambda minus 1 by lambda naught. So now using this Einstein's photoelectric equation, will explain the laws of photoelectric effect. Now, the first law is about the time lag. Now, consider this is a metal surface. There are a number of electrons. Now, light is falling on it. So, the energy of light is quantized and it is falling as some packets or photons. So the total energy of a photon is completely absorbed by just one electron. So this electron can be emitted instantaneously because the energy of the light is not shared between the electrons. An electron gets the complete energy of a photon. That's why it can be emitted instantaneously. Hence, photoelectric effect is an instantaneous process. Now, for the second law states that if F less than F naught, photoelectric emission is not possible. Now, consider this equation. K max equal to H into F minus F naught. So, if F less than F naught, K max is negative. So, if frequency of light is less than threshold frequency, maximum kinetic energy becomes negative, which is an impossible concept. So, photoelectric emission cannot take place below the threshold frequency F naught. Now, the third law. Stopping potential and maximum kinetic energy EV naught equal to K max. It is equal to H into F minus F naught. So both V naught and maximum kinetic energy will increase with increase in frequency F, because K max is directly proportional to F minus F naught. Now we'll go for the fourth law. The photoelectric current depends upon intensity and independent of frequency. So first understand the thing intensity. According to Planck's quantum theory, intensity means number of photons per unit area per unit time. So if intensity increases, number of photon increases. As photoelectric effect is one photon, one electron phenomenon, if the number of photons will be more number of electrons are emitted. Hence, photoelectric current increases with increase in intensity. Now, if keeping intensity frequency is changed, that means energy of a single photon increases, but number of photon remains constant. Now, as it is a one photon, one electron phenomenon, if intensity remains constant, number of photons remains constant. That's why number of emitted electrons also remain constant. Hence, photoelectric current is independent of frequency. So, next we will go for the V0 versus F graph. Now we will observe V0 versus F graph. From Einstein's photoelectric equation, E V0 equal to HF minus W0. So, V0 can be written as H by E into F plus minus W0 by E. So, if we compare this graph, it will have the form Y equal to mx plus c. Now, y equal to mx plus c represents a straight line. So, V0 versus F graph is a straight line. Now, slope of the graph equal to h by e. That implies h equal to e times slope of the graph. So, if we draw the graph for different metals, this slope is h by e, which is a universal constant. So, slope of this line is parallel straight lines for all metals. Then, if we go for V0 intercept, it is equal to minus W0 by E. So, W0 equal to minus E into V0 intercept. So, this point will be minus W0 by E. So, how we can obtain the work function from this graph? Work function equal to minus E times V0 intercept. The last one is threshold frequency F0. Now we know W0 equal to HF0. So F0 equal to W0 by H. Now W0 by H, it will be minus V0 intercept divided by slope of the graph. Or we can say the frequency at which this graph intersects the frequency axis gives the threshold frequency F0. So, this is the explanation about V0 versus F graph.